The presentation is JSON and Solr from top to bottom. When I pitched this presentation, just truth in advertising, I thought I'm going to show you all of this. Once I started preparing for the presentation, I realized that's more a book than a talk. So we're going to be somewhat less ambitious. If half of you want to get up and leave at this point because you won't get that whole slide, I will not complain. You can catch me later. However, some of this stuff could be booked later as well. So if you have any thoughts whether or not you walk out, I would be very happy to hear them. I've chosen this topic because it's a little bit confusing, especially for beginner users, to try to understand all the different information from different parts of the reference guide. And also there is some confusion between custom JSON and Solr JSON, and I'm going to cover those parts. So that's what we're actually going to do. So we're going to focus on a couple of areas you're going to hit right at the beginning of your attempts to get Solr, to get JSON into Solr, to use JSON for configuration, to query with JSON, and so on. And I'm going to take a reductionist approach, which is I'm going to try to reduce confusion, reduce errors, reduce gotchas. And I'm going to give you hints and tips that I found out. So hopefully we'll have time for questions, but it has never happened yet. So we're going to start from indexing. So there is a little bit of a confusion with indexing for all the beginners who try to use JSON with Solr. And it comes from several sources. One, differently from some other search products that use only JSON. For Solr, JSON is just one of the many formats that we support. And so it's one among equals, and therefore not every paradigm fits perfectly into JSON way of seeing the world, and so people get confused. More importantly, we have two different ways to deal with JSON. Solr understands JSON as a command format, so the same way we understand XML as a command format and CSV to some degree as a command format and so on. And that's when you're happy to craft your JSON for Solr's needs, it gives you the most power. But a lot of people want to say, I've got this nested JSON in MongoDB, I want to just take it and dump it into Solr. And if something is discoverable, if you can search it that way, I'm already happy. I'm going to think how to actually map it to be used for search later. And when they can't do that first step, they get lost. They're like, I can't use it at all. Now, we can talk for the whole lecture why that's not the correct approach, why you should be starting from the queries backwards and modifying your data to fit Solr, search needs. But that's a different talk. Hopefully somebody else is doing it. So, but we do need to give an easy way to do that. So we do that, but because there is also Solr JSON, there is some confusion. So we're going to focus quite a bit on that. And then there is like, what do you actually send? Do you send an object? Do you send an array of objects? Do you, different permutations? We try to make it easier with providing several different endpoints, update JSON, and update JSON docs. And I will explain what they mean. Unfortunately, too many choices, too many good things sometimes become bad thing. And so now people saying, great, we have so many endpoints, I'm confused which one is which. Not by the end of this talk, you'll know. I will give you a nice tool. So there is a bunch of little things all together. So we're going to explain how to make it all. I'm going to explain, sorry, co-presenter is not here, never was. I'm going to explain how it works. But first, let's start from what seems like an easy question. What is actually JSON that we are talking about? And we all know what JSON is, right? I mean, quoted keys, quoted values, numeric, and so on. You can have nested children, arrays, all these things. Well, that sort of works if it's all machine generated. But if you want to do it by hand, or if you want to sort of take shortcuts, sometimes it helps to do better things. So one of the barely documented parts of Solr is that we actually take quite a bit more in our JSON, the JSON that we consume, so that you can send to Solr. We actually allow to have comments. We can allow to have keys without quotes, which makes it a lot easier. We allow to use single quotes, and we allow trailing commas and a couple of other things. And this is done by a project called Nogit. which was built by Yonik Sili. And so I give you the links to that. That particular extension, as far as I can tell, that's a particular extension that also understands JSON lines for those who know what that is and are interested in that. So that's kind of streaming JSON going into the document one line at a time. So hopefully, if you leave now, you already got something good, because that means you can document the JSON queries or the JSON documentation strings that you send to Solr. You can put that right in a file, and it will happily ignore it or deal with that. OK, now we're getting to the core of this. So we're talking about indexing JSON, and there are two different ways. So there is a Solr JSON, and there is a custom user transform JSON. We use different names different ways, different times. But that's basically the taxonomy. You have the Solr, and you have the whatever random JSON comes from your system that we have. So for the Solr JSON, we can handle the documents. We have the children document syntax to create the children structure within Solr. We support atomic updates. We support commands. On the other hand, for the custom JSON, we try to give you some sane handling, and we give you configurations to allow you to do more custom things for what you want. And it allows to store source JSON, because it's a common use case sometimes to try to store source and maybe not everything else. The important part for you, you can rewatch this presentation later. It will show up on YouTube pretty fast. The slides I will put up on SlideShare tomorrow. The most important thing I want you to understand, guys, and we're going to be walking through it, is if you hit a problem, you need to go back to this and say, which of these JSONs am I trying to use, and which of these JSON does Solr thinks I'm using? And so we're going to see how that fits together. So be very clear about that, because the same document may process in different ways. And also some of the features may look like failures because they're not what you expect, but it was actually correct due to some parameters. And some failures may actually look like partial successes. And you will be wondering what happened if you don't look in the logs. So we'll have example of that. All right. So there is 3 indexing endpoints. Only 2 of them really matter, like really distinct, and one of them is kind of wishy-washy. So the classic one is /update. That's the one you could send everything to. You could send your JSON, you could send your XML, you could send your CSV. That all goes to that one endpoint. And then it figures out what it is based on the content type. So if you tell it that it's application/JSON as a primary or text/JSON as a secondary type we recognize, it will say, oh, it's JSON you're sending me. But it still doesn't know which JSON it is. Is it Solr or is it custom? All right? If you send it to update/JSON, you don't actually need to provide content type. It kind of overrides the content type and says, I know it's JSON. It doesn't make any other assumption, but it says, I know it's JSON. And that's important because some of the client systems sometimes don't allow you to set content type, or you have to really bend over backwards to be able to do that. And so this is a useful endpoint kind of to say, I'm not going to set it, but Solr knows to only expect JSON. And the last one, /update JSON docs, that's the one that says that's your custom JSON only. Do not send Solr commands to it. It will mess it up. But when you send it to /update or /update JSON, there is a parameter called JSON.command, which will specify which of those 2 you mean. And if you're using bin post command, which is a very comfortable way to do that, there is a flag for that, -format Solr. If you don't use it, it assumes it's a custom JSON. That's fairly new. Those of you on version 6 probably have it the other way around. But in the latest Solr, by default, we're assuming it's your custom JSON, and we try to do same processing on that. So you need to tell explicitly to bin post command that it's Solr JSON. Unless you do something extra interesting that I'm going to show you in a second. All right, so let's understand the bin post, because that's what a lot of people use kind of thing to start with, just to push stuff into Solr. Oh yeah, well, let's look at the basic JSON. I think that's as basic as it gets. One object, it has a key, it has a value. You can see I'm using our extension. I'm not quoting the key. All right, so let's create a test test collection that we're going to use it for. So just usual bin Solr create -c test1 uses the default config set. which has schemaless mode enabled. So I'm not showing you how to create the fields and so on. And the schemaless mode is, for those who don't know, is actually a pipeline of update request processors. It's a whole separate talk about how you can play with that and tune it to your needs and put the date formats that actually in use, not the 5, whatever it was, formats that we thought might be useful and so on. But there is an issue that can really bite you in the tuhis? Which word can I use? That can really bite you in your rear if you're not aware of it in a sort of edge case. And that's specifically for the child documents. We have a problem at the moment that we're aware of. We're trying to figure out the way to solve it. But the update request processors, which are part of that schemaless chain, do not work with the child documents. So if your child documents if your parent document in a schemaless mode has a field that hasn't been defined yet, it will work. If your child document has a field that hasn't been defined yet, it will trigger that bug, and it will say, I don't know what you want me to do with a child key name thing. I don't have a field for that. And you'll be going, but I have schemaless mode. Okay, it breaks down for this particular edge case. So that's just one of those things that can beat people with a nested JSON. So it can fail to generate IDs and stuff like that. So just be aware of that. And the answer to that is you just explicitly create the field that it expects, and then it will work. Though if you don't have IDs, you're kind of in a bit of a trouble. All right. So continuing with bin post. We are sending that basic JSON to our new collection, right? And we're just doing bin post -c collection name, that file. Okay, here's the important thing that command tells you for you to debug whether your expectation and your reality match together. So I put that in bold. So it tells you that it's posting a file called basic.json. It tells you the content type it's going to use, which is application/JSON. And it tells you where it's sending it to. So base is your base like update URL, and then says, I'm sending it to JSON docs, right? So it's treating that as a custom JSON. This is a very important part, right? And it also tells you, like there is more logs in there, but these are the 2 lines that are really important. It also tells you that it's committing. So it issues a commit, so that document you send is now visible. Sometimes when you do it from a different client, they don't issue the commit. You send stuff in, you're going like, where's my document? Did I do something wrong? No, you've done everything right. You just forgot to commit. It's still pending in the queue. Ask me how I know. Don't ask me how I know on record. So that creates a document. So it just creates a standard document because it's in a schemaless mode. It auto-generates IDs, and it sticks a version there for the versioning thing. Okay? So important, because you're auto-generating ID, if you rerun the same command, you get the second version of that document, right? Because it doesn't know it's the same. It just generates the ID. That's a usual problem with a schemaless mode, obviously. One of many limitations of trying to do things that way. All right, so now let's take the same document and send it to actual JSON, to actual Solr JSON. Tell it that it is. All right, so same command. We say it's a format Solr. Okay, so it tells you that it's posting file basic.json. It's still application JSON, but it's going to a different location. Okay, that's how you know what happened, right? Because sometimes it's confusing. And it's going to fail because it doesn't recognize that format as a Solr command document. It's not the structure it expects. It's not a Solr structure, right? And you can see the full stack trace in the log file. So that will give you the whole sort of complaint about it. Okay, here's a little tricky one of those things that will bite you. You can actually send your JSON in line, which is very useful. But when you send it in line, the bin post auto-detect of the content type or routing or whatever from the file extension does not work because it doesn't know, right? So it's going to send it, and it tells you, I'm posting whatever you gave me, args, to /update, not to /update JSON docs, right? So now you know that it doesn't know where it is, right? And it also doesn't tell you what content type it's sending it with. It's not using any, so it will use like default. And so Solr will actually say, oh, I'm expecting XML, and complain, right? Now, if you do a lot of tech support or whatever, you will recognize that that's complaining about XML. You can reverse engineer that, oh, that's what's happening. It's XML, not JSON, and so on. I'm showing it to you for those who hopefully don't have to do it too often, right? So the solutions are out there. You can say it's a content type. You can send to a specific URL, so to update JSON, the one in the middle, and you can tell it that it's Solr. Then it will work. And then it will fail because it's still not a Solr JSON document, but it will get to the point where it fails for the correct reason. So what does a Solr JSON document looks like? Okay, well, that's what it looks like, right? So you kind of have the additional structure because you have a series of commands in there. So you say add, you can have some additional parameters like commit within, then you say doc, and then you actually have your JSON of the doc, and then you have other things. In addition, you can have, so you can also do, for the Solr JSON documents, you can do an atomic update. So you can see it sort of looks nearly similar, but as a nested object, it says what it actually wants to do, right? We will come back to that later, right? If this was a small, younger class, I'd be giving out candies for figuring out when we come back to that, but. Okay, so here's the other commands you can do. So if it's that particular format, you can also do commit, you can do delete, you can do all these different things. All right, the important point to notice for those who are generating this from a client that uses JSON library, this is not a quite true JSON, even ignoring the extensions that we support, because you could generate it with all the quotes in place and so on. But we are supporting linear, like we're supporting multiple commands in a sequence. So we're supporting multiple keys of the same name, right? So if you're, because XML has an expectation of linear, but XML knows it's a sequence of elements. JSON is a map. So your client may rearrange things in a random order and send them in a random order. So you may add everything and then delete stuff. So just be aware of that it actually has the implication of it being linear. And that can get you. So the order matters. As an example where it's really useful when you're doing a lot of prototyping, so there is a delete command you just do from command line. You're just saying, remember you have to say it's application JSON, you have to say, you have to send it to it goes to the default /update endpoint, and then you just give a query straight in the line. I find it very useful because I can pretty much type that from the memory. I usually forget just one column. So I can type it from the memory on the second try. All right. It supports child documents, explicit child documents. So you need to have a key called _child documents _, and then within that you have an array of child documents. And it knows what to do with them as long as you don't have any fields you haven't defined in a schema yet, because you'll hit a bug otherwise. Okay. So that's where I would be giving out candies, because the child documents look very similar to the atomic update records. Right? And that's a silent partial failure if you don't use _child document _. So if you just have the generic child, it will not put the record in, but it won't put the record in because in the server logs it will be complaining and saying, I thought that would be an atomic update, but it doesn't look like any I recognize, so I'm just skipping it silently. So you'll be wondering what happened to your child document. So that's kind of, okay, you don't see that message. So that's kind of what happens. So that's where the challenges come with the child records and things. We are redoing the way the nested stuff is handled. For XML, for JSON, for all the formats, just the way it's handled. So you can have a look at the Solr 12298 work in progress. There is some new stuff that came out just in 7.5, but it's supposed to be sort of still semi-invisible, and there will be more work happening for version 8 coming soon. But what it will let you do, it will let you have those tagged children, and it will have better understanding. It will actually know that it's tagged with that key. So it will preserve the hierarchy better and so on. But it requires, at this point, it sort of works, but it requires some configuration to make it fully work and so on. So for those for whom this is important, get 7.5 and test the hell out of it, because there are probably edge cases that we haven't covered, and the faster we will discover them, the faster it will be available for everyone. So try using it. If you can't figure out, you can talk to me. I'll help you figure out together, because that's kind of an important new feature coming in. So, but you do need to predefine the child fields. And the way it knows to use this new functionality is it looks for unique key being present in a record, so for the ID to be present. So not auto-generating IDs for this one. If it's not seeing an ID, it will assume it's atomic update. So that's why we really would like some feedback of people who would use it in their pre-production environments, in their development environments.
So could you call it, so instead of the word child, you could have the word kid?
Yeah, any. Yeah. It's
the fact that the ID is at the two levels.
Yeah,
Important.
exactly. It's the fact that the ID in the child record has an ID, is that identified to the new code to say that, oh, I actually do want it as a child record. Okay, and it will generate the standard Solr several documents, which internally actually represented as block and needs to be treated as block. You know, if you delete, try to delete both of them and so on. But in the new code, not in this example because I haven't shown you the configuration for it, it will introduce additional information to make it very easy to see that it's part of the same tree kind of thing. Okay, special case. I showed you how to send one document in the command structure. You can also send an array of documents, just an array of JSON objects. The important part, if you send this to Solr JSON, it will still support the rest of the Solr JSON additional functionality, such as partial updates, atomic updates, child documents, and all the rest of the things. If you send it to JSON docs, it will treat that as a generic JSON, and it will just process it without knowing those additional things. And we'll have an example of that. All right, so now we get to the custom JSON transformation. Repeat with me if you want to. Solr is not a database, right? That's a mantra we have to tell to the people who come to us and say, I want to dump my database into Solr. And it's like, well, we'll make it a little bit easier for you, but you're kind of shooting yourself in the foot in a medium term, because garbage in, garbage out, and the database structure is not quite how Solr expects its searches to be structured and found. So it's not about storage, it's about search. However, we still try to make it easier for you to map your JSON, at least as a step one, before you know what to do, before you can analyze your data and so on. So this mode, the JSON docs mode or non-Solr command mode, supports mapping JSON documents to one or more Solr documents. It can do splitting. It can do field name mapping. It also supports this special mode where you store just the ID, and everything else goes into a separate field, like combined, like a text field. So when you do your search, you do the search against that field, you get back the ID, you look that up in your original database. That's quite a valid mode for some people. The only problem is that text field, in all the examples, it's stored equal false. So if you run against that configuration, not expecting it to be there, you will go like, where's all my fields? And because you don't actually see any content, you just see the IDs. Specifically, this is a tech product example configuration. So any of you who are using tech product example and trying to dump your custom JSON will hit that. And people did and couldn't figure out what's going on. And so this is a gotcha. Okay, there is a long list of parameters. So the default configuration, so it's on their JSON docs endpoint. You can see what the configuration using config API. We'll get to config API later as well. That's just a foreshadowing. But some default parameters are actually hard-coded if you're trying to really understand. So that's what they mean. Split equals slash, which means we don't split. We push everything into one document, the whole nested structure. And we auto-map the fields to the fully qualified name, right? And then you have the other parameters. So the map unique key only is the one that doesn't actually map the fields themselves, but dump them in one field. Okay, and that can take single JSON object, array of objects, and it can take the JSON lines again, so the streaming one. I give you links for later, so if you review the presentation, you can follow the links, because not everything is very obvious where it's in the commutation. I'm trying to link into it as needed. So what do you get? All right, so we'll take our nested document. We'll take our Solr JSON nested document, and we'll send it to the other endpoint just to see what happens. And you can see what happens, right? It fits it all into one document, and it auto-generates the names to sort of reflect the depth. And then you can search it. So if you see that when you expected real documents, that meant your wires got crossed, your beams got crossed, and you send it to an unexpected place. So that's kind of a debug hint. If you see that, you've gone down the wrong path, the wrong endpoint. Okay, so that was indexing. If you grokked all that, if you understood all of that, I think you'll be okay with, what's going on kind of thing, bearing bugs and other things. So let's have a look at the output. Okay, so returning Solr documents as JSON, right? So we used to return XML by default. Now we return JSON by default. So if you're doing the admin UI searches or you're just hitting the select endpoint, you're gonna get JSON back. We also have a query endpoint which basically does the same thing. Not sure why anymore. Maybe it will go away. You can also explicitly specify it if you have your own endpoints or if you wanna do different things at different time. And so you can specify the response writer to be JSON. So if you have a field which contains a fragment of JSON, this is one of the nice things, a fragment of JSON, you can actually inline that when you return your object. You could say that this particular field, don't return it as a string, but return that as actually inline JSON. So that's sometimes useful for those who wants to store, I'm not recommending it, but for those who wants to store sort of additional parameters that they're not actually searching in any meaningful way, but they want to return that. Repeat after me, Solr is not a database, but if that's where you ended up, this might be useful. Okay, so the transformer, it's kind of one of the hidden things. So I give you a link. You can also, when you export everything, you can do bulk export, which exports all the records, and that uses different endpoint, and that uses JSON as well, and it needs to be configured. You need to give the right parameters. It needs to be doc values. The full explanation is available. So, but you can do it like I give you a line against the films example, which ships in a Solr example films directory. I'm just showing you. It's not the best example, but it's the one I don't need to explain how to configure because it comes with its own README file. Okay, we have some additional specialized functionality that also uses JSON. So real-time get to see the documents before you commit them. So sometimes people need that. Stream and graph processing in a Solr cloud endpoint. The stream endpoint uses JSON, and parallel SQL, which is built on top of stream, is also produces JSON at the end. I'm not going to cover those. There have been fantastic talks on those things at previous conferences. You can just Google that. You can follow document references, things, and so on. If you weren't aware that we have those bits in Solr, well, you get something new for free. Okay, querying with JSON. So now we're getting into really interesting thing. So traditionally, when you do the search, you give a bunch of parameters, potentially very long list of parameters, your standard Q, FQ, whatever is generated from admin UI, right? If it gets too big, people sort of know that, but maybe not necessarily off the top of their head. The reference guide may not be quite mentioning that, but you can actually post your parameters instead of sending them in a GET and hitting the whatever it is 2K limit on the proxy, URL links. You can actually post it to Solr. Or yeah, you can actually do a get, but with a body, but that's kind of weird. But we have examples for that. You just need to make sure you're using application X form URL encoded, and curl will do it for you. So if you're using curl, you don't even need to say that. Okay, but so that's good. You have get and you have post, but they're both flat. So they're just your standard old list of parameters, right? So and it gets messy with very long parameter names and all these things, and it's kind of. So there is more. We now have something called JSON request API. And so instead of the URL encoded parameters, you can pass a JSON body, right? And so there is an example where I basically did the same thing, and I'm passing it in. But notice that the parameter names are not the same, right? This beat me in my, like 3 times before I reread the documentation enough times to understand what am I looking at, right? So this is really important. Whoa, okay, 10 minutes, right? We'll see it, and I'll show you the thing. So there is a mapping between the parameter names, but the rest of the parameters can overflow into a block. So this is a side-by-side representation. So the old style is a QFQ and rows, and then for some of them, if you want to use thread in a JSON document, it uses different names. I'll show you which ones. But you can use the old names in the params block. So you kind of have this workaround. The important part, you can also mix and match. So you can have some of the information coming from the query line and some coming in the body, and you can even have macro substitution and all that stuff. There is a lot of power in there. Okay? And so this is the one that I'm mapping. Okay? This is all in a reference guide. It's just presented in the opposite order from the way that makes sense. I might be fixing that like in a couple of weeks or something. Trying to fix that. Okay. So now I just want to show you an example of JSON query DSL. So now that we have JSON, we can do mapped objects, map nested objects of the queries. Some of you consultants probably are going, that looks familiar from possibly other products that are not quite Solr. And it's true, right? We're all using Lucene under the covers. And so now with this particular, with the JSON query DSL, you can actually send very similar, programmatically build nested query request. And it can actually get even more verbose than that. I just didn't fit into the slide. I gave you the middle version. But that's what it is. With the Boolean query parser, you can do that kind of thing. So you reduce the magic. You can reduce the magic of the parameter names and actually have the structure. Okay. Now that we have the JSON query DSL, we're building new functionality into that. The biggest one of those, and kind of the big first one, is the JSON facet API. So that replaces the JSON facets we have, and it makes possible to express multi-level faceting. We sort of had 2-level faceting. You could do the pivot, but other things didn't work and whatever. Now we have that unified, and it's done through this pathway, through the JSON query. So that's a bright, shiny future. And Yonik is doing presentation on it tomorrow, I think, giving you the super exciting new stuff that's coming into that. So I'm just going to show you what's already there, right? And you can do super advanced things like semantic knowledge graph, which does a relatedness function between different subsets of documents against the background set of documents to tell you if there is a relevance between, if there is implicit relationship between the C of the. If anyone can explain it to me like I was a 5-year-old, I'd buy you lunch. But it's documented, and so for the people who do advanced sort of analysis, it's actually quite useful. So I do have an example. But I wanted to show you a big JSON facet example. Well, it's kind of medium JSON facet example, but it's bigger than, this is all continuous part. It's bigger than the example. And what it is, I have a data set of dogs and cats, and then I'm asking to find all animals with a variation of gray color, and then limit those of age between 0 and 20, show first 2 records and facets, then facet by animal type, then by breed, and then to show counts by the buckets. This is from my example I did 3 weeks ago at ApacheCon. You can see the link to, you can follow to the full example. That was 50-minute presentation on its own. So this is, I'm passing this by reference, not by value. Java people in the room? Okay, finally, configuration with JSON. So it used to be super simple. It used to be managed schema, or it used to be schema.xml for those who've been here long enough. Managed schema these days and Solr config.xml, and everything else was defined in those 2 files, and you could follow the reference and so on. Not so simple anymore, right? So we now have an implicit configuration, which is not anywhere in the file. It's API driven, which is good and slightly confusing, but hopefully not after today. And we also have a couple of managed resources, which is the beginning sort of that direction. So managed schema. So we have an API to read this schema, right? And most of the things you would really change more than once, you have write access to. So you can add and delete fields, dynamic fields, field types, and copy fields. And most of this is exposed through admin UI, though not the field types. That's still like sort of by hand API call. Some of the things is not yet an API, like unique key, which hopefully you don't need to manage via API too often. And there are 2 APIs, one version 1, one version 2. It's kind of confusing which one you need to use, but version 2 is mostly for the cloud and so on. The important part is when you use API, the changes are live. So before you edit the file, you reload the core, you reload the whatever. Now, especially with the Solr Cloud, you push it, it's live. You don't need to do any magic yourself. You don't need to worry about the state discrepancies. Of course, that will override managed schema. So if your critical comments are in the managed schema, well, version control or get them out of managed schema, because on the first API modification, it will be gone. Okay, also connected to the schema, we have some managed resources for analyzing components. We just started on those. So for the stop filter factory and the new synonyms filter factory, you can actually manage them via REST API. But you do need to reload the core collection after you did it, because it's kind of second-tier resource modification. It's not smart enough to figure it out. So that might be useful for those of you who are sort of have the full life cycle of dynamically managing your stop words and synonyms and stuff like that. It might be a little easier. Okay, manage configuration, Solr config.xml. Used to be just Solr config.xml. Very importantly now, okay, we have a Solr config.xml. We have implicit configuration that you can only access through API. We have config overlay that overlays the Solr config. And we have params.json, which is super useful, but you need to know it's there and you need to reference it correctly. You have read-only API to get everything. Notice the additional parameter to show truly everything. And there is some sort of subsets of things you can call if you just want partial information. That's all in JSON, of course. There is several write APIs, none of them fully affecting all elements of Solr config.xml. It's still a complex beast, that file. Okay? The overlay file, config overlay.json, that's how you modify it. Solr config.xml itself is not modified, not rewritten. Your comments there are safe, sort of. They shouldn't be there, but it's safe. Because when you use the API, it will create an overlay file. And whatever you set in the overlay file will take priority over the stuff. Very long list of commands. I'm not going to even try to fit them on 1 or 2 slides. Just go to the guide. It tells you all the things. It gives you examples, V1 API, V2 API, and all that stuff. It's a little messy, because it's not a flat file, it's a little messier in the API. But, it's just there. Like once you figure it out, it works. Okay? And then we have request parameter APIs. And it's just for those defaults, right? For the defaults, invariants, appends that you have in your request handler, on your select, on your query, on the custom thing you create for your domain-specific things, where you lock some of the parameters, create variables and all that stuff. There is an API to create those. And request handler can take multiple of those, like multiple param sets, and you can specify them on command line. So it's actually useful during indexing. You can do A/B testing with that, where you record one configuration in one param set, another in another. You put it all in your Git control or whatever. It's just easier than put stuff in there. Then, it gives you the easier way to put stuff in there than doing it as huge param sets. My ApacheCon presentation from 3 weeks ago also has an example of that towards the end. And finally, before the girl shows up for the third time and kicks me out, right, so updates are live immediately there. And we are done. So, we probably have time for half a question.
So can you just clarify for us beginners here, differences between schemaless, schema, managed, and not managed? These sort of four concepts.
Yeah, sure. So not managed schema means you had a schema.xml file. You only could modify it by hand. You couldn't modify it by API. It's sitting in your directory. And it was basically locked down the way it was written. That's not managed. We don't have that anymore. I mean, it's still there. We rewrite it on the first access. It becomes managed. Yeah, half a question. It becomes managed schema. You can still lock it down with a special parameter in Solr config.xml to say it's managed schema, but suddenly it's read-only. You can actually do that, right? That's managed versus non-managed, right? Versus classic. Schemaless mode is, I get points for this word. It's abomination that is there for people who do not want to think about the data they feed into Solr. And so what it looks at the first instance of any field and tries to figure out which field type it is, right? And if you want to see why it's abomination, have a look at the films example. Because the films example says you have to explicitly define the movie name because the first movie name, being in alphabetical order, is 22. And so the schemaless mode goes, hey, it looks like an integer. I'm going to create an integer field. Hits the second record. Second record is a string, blows up. Your schema is already modified. It's not safe. It was created for people just to have the first go. Unfortunately, people who then go in with it in a production are confused why their production blows up. Fortunately, the other product does exactly the same. Right? So we're kind of in the same boat on that. Like, it's abomination for both of us. Right? So we are actively discussing doing that as a maybe sort of sidecar thing where you could feed your documents against a different endpoint and it will come back and tell you what it should be, but let you make the choice yourself. Work in progress, right? Because, like, what do we actually tell you what's the significance? So that's what it is. So basically, if you can avoid schemaless mode, just avoid it, right? If it's there as a crutch. If you know it's a crutch, like for my examples, it's fantastic, right? I haven't created a single field definition. I just dump stuff and it automatically creates the fields. But I'm not going into production with what I'm showing you, right? So this is just like, okay, one last slide. But in real life, schemaless mode is like, if somebody says it's a solution, fire that person. If it's you, talk to me longer after we get kicked out.